Do you think I should talk to you about the? Do
Sorry, I just
you
hit
think I should?
record. Okay,
No,
sorry,
it's
go
fine.
again.
Do you think I should talk to you about the assignment first, or about the new lesson?
I don't know. When's your assignment due?
Next week.
Okay, so we have a lot of time on that. Let's
Hmm.
talk about the new lesson then so that you don't get behind. And
Uh,
if you want to send me the assignment over, I can make you a video and send it back to get you started on that.
oh, you would do that in your off time?
Hmm.
Oh, okay. Thank you so much. Let me just we have to do it on Sage Math, which is like the only confusing part.
Yep.
Just a second. Sorry, I just have to sign in to my account for the fifth time. Uh, Calculus.
So I don't know if you're aware or not, but with Sage Math, if you go to the free one on the cloud, there's a chat GPT built in that gives you the code that you need to do whatever you're being asked to do. And
I
that makes
see.
it so much simpler. So yeah, so if you're stuck on code or code's not working, it will actually even troubleshoot the code for you and tell you what's wrong with it and give you suggested corrections.
I apologize. It's not that I'm not paying attention. It's just I'm trying to send this to you.
I understand.
So
Do
all
you
right,
want to just
just a
share
sec.
it? Mhm.
Yeah, no, I'm trying to send it to you. Or
Okay.
wait, do you want me to share my screen or send it to you through
Yeah,
email?
you can share your screen. That might be faster.
Okay, sorry about that. Just a second. As I do that, what were we talking about ChatGPT again? Well,
Yeah. So if you go to like the free version of Sage Math, if you just search it up on the internet, there's you're going to get one that's got a chat GPT built into it. And so if you
mhm.
are trying to code for finding the derivative of a function or whatever, you would just ask it, what's the code to do this? And it'll give you the code back. And then you can just run it. And if you have problems, if there's any errors, then it will self-correct. It'll say, okay, well, the problem seems to be this, but if you change this to this, it should work. So it might be worthwhile looking at that as well. Okay.
Okay,
All
I
right.
see. Also,
So
now that I'm looking at the assignment, it doesn't look too bad. At least the first couple of questions.
use sage math to plot. Yeah. Use the graph to guess at the roots. So the roots are going to be where you cross the x-axis. And so if you plot it using Sage Math, that should be very straightforward. You can just plot. I think the code for that is just plot. And you have to hand in your graph as well, I guess. Yeah, probably have to hand in your graph. So you
How do
want
I
to
hand
plot
in
it.
like a graph? Like, would I have to draw it or something like that?
Yeah, it'll draw it for you. So you'll just put in plot and then your equation. And then you're going to put in the limits on x, the interval 0 to 3. And it will
I see.
plot it for you. And if
Okay.
it crosses the x-axis in that interval, then you can estimate what those points are from the graph that you get. So
Yeah.
any x-intercepts. Okay. You could have as many as two, but as few as 0.
Okay.
Okay. So this is your assignment for next week. Is this also what you guys were doing in class today, or what were you learning
Uh,
in class?
or let me show you. Let me show you what I did yesterday because I
Okay.
didn't have any classes today.
Okay.
Uh,
So yeah, if you want to send me a copy of this assignment, I'll help you out with the coding and show you what it should look like. And we've got lots of time on that because it's not due until next week, right?
mhm.
Hmm.
Let me just a second. Okay. Wait, let me just.
Hmm.
Is it okay if I stop sharing my screen just for a second? All right. Sorry, I just need to do something real quick. Because I'm just trying to figure it out. I found it. All right. Let me just go to my school account. All right, you should get something right now.
Did you email it or are you sharing it?
I emailed it.
Okay, go get it.
Did you get anything?
Yep, I just didn't know where to look. Hang on. Okay, so that's your Sage Math one again?
And this is what I did yesterday in Stefan's class.
Oh, you sent me the assignment.
I sent you the assignment?
Yeah.
No, but I sent you, but isn't that what you wanted? You wanted to take a look at the assignment?
I
Or you
thought,
wanted to see the lecture notes?
yeah, I thought we were gonna wait on the assignment. Remember I said I can make you a video and help you get started on that?
Oh,
Uh,
okay. Sorry about that.
no, no.
No, it's all right because I'm sending you the calc notes right now. I just thought it'd be more prudent to just send it to you right now.
Yeah, okay, no worries.
Uh, just a second. Just a second. Okay. You should see something right now. Sorry, I apologize. I should have been more organized. Um, I don't mean to waste your time.
No, you're not wasting my time. I can't see a shared screen yet. It's not coming up
Oh
yet.
no. Oh no, I sent you an email.
Oh, you said
Oh,
it.
I can.
Oh, I'm sorry. Okay, got it. Okay,
No,
yep.
yeah, because it's a little difficult because I gave you my notes from the iPad, so I had to like copy it to the iPad from the laptop and then
Mhm.
copy and paste that onto the email.
Okay, no worries. Um,
I
oh,
also I
is he doing the hyperbolic functions again this year? Wow,
yeah
that's nasty. All right. Oh, I'm gonna share that.
I made sure to tell you which ones were at different times because just a second. Yeah, actually, can you even see that? Oh yeah, classes on Monday. First one was in the evening, so the lecture, which was like an hour, or almost 2 hours, and then the other one was in the morning, which was only 50 minutes. It was with the Maya. She was teaching it, if you know who she is.
I don't know Maya. She must be a TA. Is she in the course?
I'm assuming she's a TA because she's too young to be a professor. She looks like a student.
Okay. So, all right. So looking at this one, he's doing the hyperbolic. Well, no, he's not doing the hyperbolic function. He's doing the e to the x function. Okay. So he's going through the derivation of where the derivative comes from. for the exponential function. And he's using the definition of the derivative here. And that's the same as the other ones that you've been doing with f of x plus h minus f of x. Okay. So
Mhm.
what he's doing here is taking e to the x and he's adding just a tiny bit more to the exponent. And then he's subtracting the original function e to the x from it. So when he factors out e to the x from both terms, then we should have brackets here around, oh no, okay, no, brackets in the next one, right? So he's showing you where the two factors come from. In the next one, he's doing a common factor here, okay? So each of those terms up here has an e to the x and an e to the x. So he's taking that out as a common factor. And the leftovers are e to the h minus 1. And then we still have an h on the bottom, so we can't cross the h out like we usually can when we're doing these definition problems. So then what he's going to do is take out e to the x as a common factor here using the properties of derivatives. And he's just going to find the limit of the other part. And that e to the h here, anything to the exponent 0, equals 1. So I think that's what he's trying to tell you here is that if we put e to the h to the exponent 0, it would be 1 minus 1 there. No, that would give us 0. How's he getting that? Let me just think about this one for a sec. Of e to
You
the,
know, the problem with some of his lessons is that he often goes through stuff very extensively, and then at the
Mhm.
end says, "Yeah, I'm probably never going to give you guys this ever again." And I like,
Yeah.
so it's like, why even do this to us in the first place? Like, I
Mhm.
don't understand.
No,
Like,
exactly. Yeah, and
like,
you guys are learning the shortcuts right now. And so what he's doing is just not giving you the shortcut directly. He's showing you where it's coming from. And the gist of the lesson here is that anytime you take the derivative of e to the x, it is its own derivative. So you get e to the x when you take the derivative of e to the x. A lot of
okay.
mathematicians will refer to it as e to the x never dies because it always stays the same. And so that's what he's trying to prove. Um, it's just this e to the h minus 1 equals 1 that I'm having a bit of a hard time with right now because e to the h minus 1. Um, I'm not sure how he gets that e to the h minus 1 equals 1. That would give e to the h equals 2, and we don't have h. Um, Nothing to the exponent 0 is going to equal 1, but then we're over 0 at the bottom too, so we can't just substitute 0 in here. I need to look up the explanation for that one because I've forgotten something obviously about why e to the h here, like why
Or
he's,
I suppose maybe I miswrote it.
I don't think so, because what he did is he took this out, he took this e to the x out as a common factor originally, right? So this here, why isn't it annotating? Okay.
I mean, we could always just move on to the next question
Yeah.
because this is not really like I wouldn't care too much about this because he said that like he's not going to give us this
No,
anytime in the future.
no, you're just responsible for knowing what the derivative is, not how to derive it, like how to show it. Okay, so you have more questions down here. I didn't see those. Okay, good. All right. So for sine of x, he's doing the same idea using the definition of the derivative again. And he's adding a little bit more to the first or the second x value. So we have sine of x plus h minus sine of x. So then he's using the addition rule or the addition identity of sine. If we have sine of x plus y, it's equal to sine x cos y. So this here is an identity that you're expected to know from high school, from grade 11, grade 12 math in high school. Okay, so that's how you did that. And then plus cos x sine h. So this whole thing here, sorry, is an identity that's equivalent to just this in the first question. And so he's splitting it up into two fractions now. And he's done sine x cos h minus sine x and cos x plus or times sine h. And by doing that, he's doing the same idea here. He's taking a common factor out of sine x, and he's working that one down to cos h minus 1. And cos h is like the cosine of 0 is 1. So 1 minus 1 would be 0. So that's how he's getting that, sine x times 0. And in the second case, he's got cos of x times the limit of, that should be the limit of sine h here, not just h, okay? And
Okay.
the limit of sine h as h approaches 0 is 0. So he's got 0 times cos x there. So we've got the first term, sine times 0, and the second term, 0 times cos. And so we're going to end up here, just scroll down a minute. We're going to end up here with him saying, why is the limit as h approaches 0 equal to 1 if we're getting 0 times sine and 0 times cos in the previous line? And so he's showing you here why that is. Let me go back up here for a minute. Yeah, sine of x. Okay. And so what you're responsible for knowing here is that sine of x is equal to 1. And that's something that you're going to have to use in other equations when you're trying to find the derivative. What he's trying to explain here
Yeah.
I'm just trying to figure out what he's trying to explain here. Okay, so x squared plus y squared equals 1. So this whole distance across here is 1. So from here to here, all the way down is 1, like the hypotenuse of your triangle. I guess you're using it here. Yeah, okay, so here, that triangle. And so if cosine of x is your x-axis, and sine of x is your y-axis, then secant is going to be cos over sine. No, that's reciprocal of tan. It's going to be 1 over, 1 over cos is secant. So sine of x, I'm not sure how he's getting there either, to be honest, for this very last line. I'd have to go back and look that proof up because it's getting tricky at this point with the changes that he's making to show that it equals 1. He's still not coming up to the conclusion that it equals 1 at the end here. And then he just goes on to another one. Okay. So I can look up the explanation for you for that, Samuel, and try to explain it in an easier way. But I
Okay.
think the takeaway again is just that when you're taking the derivative of sine of x, you're going to get 1 for your answer, sine of x over x. Okay. And so when you're working with some of these derivatives, that's one that you have to know because it's just a memorization thing. And it's the same thing with e to the x. If you know that the derivative is always e to the x, you're going to need that to find other derivatives that contain that function within them. So it's the same thing here, where if you take the derivative of the sine of x, that you're going to end up at 1. This
Okay.
is, yeah, sine of x. Yeah.
Also, just in case, when you send me the recording for the video, this recording, could you edit out like the first like 10 minutes or something like that when we were like when I was trying to send it to you?
Okay, I'll give it a try. I haven't edited a Zoom video before, but I'll try that and send it
Oh,
over.
okay. No, that's
Otherwise,
fine.
yeah,
No, because if you don't have to, if you don't know how, it's okay. You don't have to.
that's okay. It's a good thing to learn. All right. I'm just going to go down here for a minute and um, I'm just going to get rid of all this stuff. Where did it go? See what the last one is that they're proving here. There's one more below it. One. Okay, so this is for 1 over x. And your derivative when you take 1 over x is not e to the x. What's he doing here? Okay. Oh, he's taking the derivative of ln of x. Okay. So this here is supposed to be an L. Okay. This is the
Oh,
logarithmic function of the natural logarithm. I don't know if you remember covering that before in grade 12 math. So this
to
is,
some extent.
okay. So this is pronounced like lawn, like your front lawn.
Hmm.
Okay, or LON, however you want to look at it. And when you differentiate it, the answer is always 1 over x. So what he's giving you here is a whole bunch of really quirky derivatives that don't follow the same rules as other functions. And you have to memorize those so that you can use these derivatives in the functions that you're given, okay? So if you're given a function with ln of x in it, you have to always know that the derivative is 1 over x.
Okay.
Okay, so if you had ln of 3x, the derivative would be 3 over x, because the 3x has a derivative of 3, and the ln of 3x has a derivative of 1 over. Okay,
I see.
so the other one here, oh no, this is the same one. Okay, where he's just, no, what's he doing here? X is e to the ln x equals ln of e to the x. Where does it go from there? E to the ln of x. Should be, e to the ln of x should be e to the ln of x times 1 over x. So it should be e to the ln of x over x. And I can't really read what you've got. Let me make it a bit bigger here. Oh, it's not getting bigger. What you've got in this box here,
Oh, sorry. I can read it out to you if you want. Uh, d over dx, and then log x.
log x.
Yeah, let me just take a screenshot, I guess. Let me just
Oh, I see. Okay. No, I see what he's saying. Okay, so right. So that one's not finished yet then. Okay. So you have to go, what this is saying is we're going to take e to the ln x and we're going to multiply it by the chain rule derivative, which means the derivative of just the exponent part, which is ln x. So when you're done, you're going to end up with e to the x. I don't know why it's on this thick marker. And then the derivative of ln of x, which is 1 over x. And so our entire derivative in this case would be e to the x over x. So you just haven't completed that one yet. Like you haven't got the final derivative in here. So you need to add that. Oh dear, as that's e to the x as an example of one where you would use the chain rule as well as the rules of these derivatives. Okay, so
Hmm.
that's really, really messy there. Let me see if I can fix that x. Um, yeah, so you don't have the very last step here for this example, but what he's actually doing now is showing you examples where you would use the ones that he's developed in the previous ones. So he's just showing you how to use some of these um, when they're combined in functions because they're just memorization. You've got to just take the memory. You've got to always know what your derivatives are for these functions so that you can just apply them when you're doing these.
I see.
Let me scroll down and see what else he's got for us here. Okay, so an inverse function. Okay, so you're getting pretty complicated stuff here now. What he's talking about here is inverse functions. So we used to do this in trigonometry, where I would say to you, the cosine of an angle is 0.5. What's the angle? And the way that you would do that would be to go to your calculator and you would use the inverse button on your calculator. For if I said cosine, then you want the inverse of the cosine. And so you would go in and put that in
That-
with the button above the cosine. Do you remember doing
So what?
that? Cos
Yeah.
minus. Okay. In
Oh,
uni
okay. My bad.
in university, we're going to call that arc cos now. So all the inverse trig are arc sine, arc cos, arc tan. And it means that you're doing this, the cos to the -1, like the inverse of it. If you were just working with numbers, you would just use that button on your calculator. If you're working with derivatives, you write it as arc cos, and then we have our own rules for differentiating arc cos, arc sine, and arc tan. So he's going through an example here where you're differentiating arc tan, and he's getting secant squared, which is the inverse of um, tan times arc tan. So these are getting into some pretty tricky um, derivatives this early on. I think what's going to happen is you're not going to do
Is
the
it?
trig ones right away.
Is this not normal?
No, it's
Like,
for a
have you seen this about in last year?
yeah, well, eventually, but not all at once. So usually what you do is you just start with polynomial functions and rational functions and you practice using all those rules that you've learned. And then you move on to trig, and then you move on to e to the x and logarithmic and those kinds of functions that are different and you have to memorize. So he's giving them to you all in one big package for some reason, but you're not going to use them all right away, or at least you shouldn't be using them all right away. Oh, and he is doing the hyperbolic functions. Okay. Yeah. So he's not going to get into all of these right away. It might be better to just practice on the polynomial and rational ones first, and then look at some of these more difficult ones later so that you don't get confused and overwhelmed.
I see.
Yeah, I think you'd be better off if you do that. Okay.
So you want me to kind of just like review it on my own or whatever, essentially?
No, just wait for it. Like, just don't panic because all of these harder ones you're not going to use just yet. So we can do them one at a time and you'll understand them better that way. Okay.
Yeah, because the problem is like I don't really understand too much. I'm gonna be blunt. I'm not
Yeah.
gonna I'm not gonna pretend as if I know what I'm doing and stuff like that. I mean